Hello all. In this video, we will see working of least frequently used page replacement algorithm with the help of an example. So consider a page reference string given to us. We want to know how many page faults will occur for least frequently used page replacement algorithm with 3 memory frames. Okay. So let me write the page reference string for you. 2, 3, 2, 1, 5, 2, 4, 5, 3, 2, 5, 2. Okay, and we are given a memory with 3 frames. Okay, now here we are going to maintain a FIFO queue as well. Okay, FIFO, the order in which the pages come into the memory, that order would be maintained in this FIFO queue, first in first out queue, because we are going to use this queue in case of a tie. And apart from that, we see the distinct pages are 1, 2, 3, 4 and 5. These are the distinct pages which we have, and currently none of the pages have been used, so the reference count for all these pages is 0 because none of the pages have been used yet. Okay, then we want page number 2, it is not there, so we take it into main memory, we insert that page onto the queue, and since we have used that page, the reference count for page 2 becomes 1, it is incremented by 1. Then we need page 3, same story, we bring that page into main memory, we insert that page onto the queue, and the reference count is incremented by 1 for page number 3. Now we need page 2. Page 2 is already there, so no page fault, we can simply use that page. But since we are using this page 2 again, the reference count for page 2 will be incremented by 1, so it becomes 2. Then we need page 1. Okay, then we need page 1, same story, 2, 3, and then we bring that page into main memory, it is inserted onto the queue, and now since this page 1 is used, the reference count is incremented by 1. Now we need page 5. Okay, so we look at page number 2, its reference count is 2. Page number 3 and 1, the reference count is 1. The algorithm is least frequently used. The least frequently used pages are page number 1 and page number 3. But out of 1 and 3, who came first? 3 came first. 3 came ahead of 1. This queue tells you that 3 came ahead of 1. So what we are going to do is we are going to keep 2 and 1 as it is, and 3 will be thrown out and 5 will be taken in. Now since 3 is thrown out, we will remove it from the queue. Since 5 is taken into the memory, 5 will be inserted onto the queue. The reference count for 3 will reset to 0, and the reference count for 5 will become 1 because 5 is just used, and 3 is no longer in main memory, so its reference count resets to 0. So whenever you throw out a page from main memory, you will reset the reference count to 0. So that is what you have to remember. Now you need page 2. Page 2 is already there, so you can simply use it. And after you use that page, since it is used one more time, the reference count for page number 2 is incremented by 1. Then we need page 4. For page 4 is not there, so reference count for 2 is 3, reference count for 5 is 1, and reference count for 1 is 1. So the least frequently used pages are 1 and 5, so there is a tie. But out of 1 and 5, who came first? 1 came first, right? 1 came first. So what you do is you keep 2 and 5 as it is, and you throw 1 out and 4 is taken inside. Since you throw 1 out, 1 is removed from the queue, 4 is taken into main memory, so 4 goes on to the queue. Since 1 is moved out of memory, the reference count resets to 0 for page number 1, and for page number 4 the reference count becomes 1. because we have used that page. Now we need page 5, it is already there, so we simply use it. But when we use that page, we will increment the reference count because page 2 is used again. Okay, now we want page number 3, it is not there, so there will be a page fault. Whenever there is a page fault, we are drawing a new diagram. When there is no page fault, we don't draw any diagram. Now we want to bring 3 into main memory. We have 254. The reference count for 2 is 3. The reference count for 5 is 2. And the reference count for 4 is 1. The least frequently used page is 4. So what we do, we keep 2 and 5 as it is. 4 is thrown out. 3 is taken into main memory. Since 4 is thrown out, it goes out of main queue as well, and we insert 3 over there because now 3 is in main memory, so 3 is inserted back into the queue. And since 4 is thrown out of main memory, its reference count resets to 0, right? And since 3 is again taken into the main memory, the reference count becomes 1. Now we need page number 2. Page number 2 is already there, right? So we simply use it, the reference count becomes 4. Then we need page number 5. 5 is also there in main memory, we simply use it, the reference count is incremented by 1. Then we need page number 2 again. 2 is still there, again there in main memory. So what we do, we simply use that page and we increment the reference count. Okay, and then that's it, right? So how many page faults you got? 1, 2, 3, 4, 5, 6. So the number of page faults for LFU, that is least frequently used algorithm, in this question or for this question is 6. Okay, I hope you have understood this. Thank you.